Hey all, just a quick little video about our last section in chapter 14, which is catalysts. More information in your book, but I'm going to give you just a quick overview. So you guys know from biology that catalysts are there to increase the rate of the reaction, get it started. And the way that it does this is by decreasing the activation energy. So we learned a couple days ago that when you look at the energetics diagram, the higher the activation energy or the higher kind of that hump that you have to get over, the slower the reaction is going to be. So if we can lower that hump, that activation energy, then we can get a reaction going faster. So catalysts don't change the reactants in the products, they change the reaction mechanism. So maybe instead of being just a one-step reaction, so if we look at the red down here, that would be an elementary reaction. So the hydrogen peroxide takes a lot of energy. So we've got our activation energy here. And then once it finally gets going, breaks down into water and oxygen, but that's a pretty high activation energy. So the decomposition of hydrogen peroxide is actually a really slow reaction. When you add a catalyst, it changes the reaction. So in this case, with the blue, our catalysts are bromine and hydrogen ions. They are going to change the way the reaction occurs. So now, instead of it just being the hydrogen peroxide breaking apart into two things, there are two middle steps. So here is the first intermediate, here is the second intermediate, that second little hump there, and then finally you get your products. Notice also that the catalysts that were here in the start are still there at the end. So they don't get used up during the reaction. They're there just to kind of move it along, speed it up. But we can see that with the blue, the first intermediate and the second intermediate are much lower energy than that first one with the hydrogen peroxide by itself. So again, you guys, catalysts are just a way to speed up the reaction. It might be like holding reactants together or helping bonds to break. So depending on the catalyst, it might have like a different function. There are two types of catalysts. You can read more about them in your book on page 589 to 590. The first one is homogeneous. So it's going to be in the same state as the reactants. So if you're working in a solution, this would be adding more to that solution, so it would also be in the aqueous phase. A heterogeneous is going to be different state than the reactants. So your catalyst might be solid, and then the reactants might be gas. And so they interact with that solid to speed up that reaction. So you can have a homogeneous, same as the reactants, heterogeneous, different state than the reactants. One example of a catalyst that you guys might know are enzymes. So those are catalysts in a biological system. It fits into that active site, kind of like a key unlocking that reaction and getting it to proceed. So I'm sure that you talked a lot about that in biology. This was just kind of a quick overview of what catalysts are. There's a lot more information in your book, which are on pages 589 through 593. So feel free to dig into that a little bit more, especially if that's something you're interested in.